Okay, so this is application of calculus, and more precisely, is application of integrals. The idea is that here's a question. So, the question is, given the curve in the xy plane, how to use calculus to find the length of the curve? Now we will consider special curve, which is going to be the graph of some function y equals f of x. Okay, so this is a over b. So how do you find the length of the curve? Okay, the calculus idea is to divide the pieces chop the pieces into many small pieces. Okay, so what you do is that you pick a bunch of points on the curves, and the corresponding point will be like this is x1. Just corresponding partition here is a is less a is x0 less x1 blah blah xn and equals b, right? Then you look at a special piece. And this is a xi minus 1, here's xi. Okay, the length still this is a curve, it's very complicated, but I can estimate this using Pythagorean theory, right? The picture here is that this is a curve. If you measure it, and this is a point, right? And I can approximate the length of this curve by the distance between those 2 points. Okay. So here it is going to be delta xi. This is delta yi. Okay. So delta yi is going to be f of xi minus 1 plus xi. Okay. So xi f of xi minus f of x I minus 1. So that's the difference. Okay, so this is the difference of y value. The length of that piece, okay, can be approximated by the length of the triangle, the third side of triangle. Okay, so the length I'm going to the arc length of that piece is going to be, let me use a notation here, the distance between those 2 points, and this is going to be the square root of, let's call it the DSI. Okay, so DSI is going to be the square root of delta xi squared plus delta yi squared. Okay, this is by the Pythagorean theory. Okay, so the length of the curve is going to be approximated by the length of this these pieces. Okay, add them together. Okay, so you cut this curve into n pieces. Okay, and for each piece you estimate the length by the length of the third side of the triangle. Okay, so let's do it. Right, this is a good estimate. Then I repress it by the right. Okay, then you take delta xi out. Okay, good. So my question is, what is delta yi over delta xi? See, delta yi over delta xi is going to be delta xi f, and here xi minus f of x minus 1. Okay. Remember, there's if the function is differentiable, then by thumb theory, we call the mean variance theorem, or mean variance theorem. This is going to be the derivative of sum xi star for sum xi star in the interval, in this interval, right? This comes from this is the by thumb theory. Okay, so you can replace that. Okay, then for the length of the curve is approximated now by 1 plus f prime xi star square delta xi, and this is a Riemann sum. Okay, it is a Riemann sum of the function. Riemann sum of the function 1 plus f prime x square on the interval from a to b. Okay, right? So if you take the limit, let the size of subintervals approach 0, then this the limit, okay, of the Riemann sums is going to be the integral from a to b square root of 1 plus f prime x squared dx. Right? So so there's good reason to say that the length of the curve is given by this integral. Okay. This is how do we get the formula. Now, the curve can be described by another type of equation. Then you have a similar idea to get the formula. For example, if this is a curve like that, okay, it's a graph of x equals g of y. In this case, and that's from C and D, that's possible, right? A curve, right? Curve can be the graph of this function, okay? This is the y-axis. In that case, by similar idea, the length is going to be from C to D, and this time it is going to be g prime y square plus 1 dy, okay? By similar idea. Okay. So I'm going to look at this integral. I'm not going to specify the formula for the function, okay? I just simply let y to be f of x, okay? So that means dy of dx is going to be f prime x, right? Okay. So the length of the curve, okay, it's going to be dy over dx square and dx, right? Simply can written this. I'm not going to mention the specific formula for the function. Okay. But formally, I can formally, okay. So something's wrong with that. Okay. Formally, we can express in this form. Okay. Now, I can move dx into the radicals, and you will get, you will get dx squared plus dy squared. Right? That's just formally. Okay. We don't know the exact meaning here, right? And this I'm going to call the ds. Okay. This is a differential of the arc length. So the length function, the length of the curve, simply just integral ds. Okay, it's very simple. So let's look at the curve here. Okay, what is the dx? Dx is this part, and this is a tangent line, and dy is this part. Okay. And the ds is this part. Okay, dx is going to be ds by the Pythagorean theory is dx squared dy squared. Okay, so roughly speaking, the length of the curve is just the sum of this tiny bit numbers, ds. Okay, add them together. Okay, so I simply write like this. Okay, I'm not going to specify the interval for the ds. Okay, s is the arc length function from here to here. The s is the arc length. So there's a third variable here. You have an x, you have a y, you also have s. S is the arc length from the starting point to that particular point. And the change in the arc length can be given by this Pythagorean formula, Pythagorean theorem. Okay, so this is just the idea. How do we get get a formula without using the Riemann sum? Okay, and if s is a parameter, so if you know s starts from 0, then the length is L, then just ds. Okay, so you can change s to x, you can change ds to y, you can change s to another parameter. So given a curve, we can describe curve in many different ways. This is a universal formula, okay, for the arc length. Okay, so if you describe, this is a curve, right? A coordinate. The curve is described by two coordinates, right? So when x, y changes, x and y related. When x or y changes, then you get the point moves around the curve. Okay, and I just to show you that ds, the geometric meaning of ds is this is a right triangle. The length of the hypotenuse of this right triangle. Okay, and so you can, so ds, you can, first of all, you have this formula, right? You can take dx out, then you get dy over dx squared dx. But you can also take dy out, that'll be dx dy squared plus 1 dy, okay? And if there's a third parameter, you can take a t out, okay? And you can take t out, it's going to be d. Okay? So that means if both x and y depend on another parameter, then ds is related to that parameter by default. So this is called the chain rule. I call it chain rule. Okay. All right. Then you can use any of this formula to solve the problem. Okay. So let's look at the problem. Find the length of the up semicircle. Okay, you can get a circumference of circle, right? Of where the radius I equals anywhere with the radius r. Okay, I is an arbitrary number. Of course, it's going to pi over 2 I squared. We know the formula, but can we prove that formula? Okay, the idea is how do you describe this up semicircle with the radius r? Okay, how do you describe it? Well, the most natural way to describe it is going to be viewed as the graph of a function, right? Up semicircle. So we know that x squared plus y squared for an arbitrary point, x, y related by this equation, right? Up semicircle. Yes. So x and y are in equal position. X depends on x, y depends on x depends on y. Doesn't matter, right? So if you view the up semicircle as a graph of some function, then that function should be going to be 1 minus square root of r squared minus x squared. And the x is between negative r and positive r, right? You just solve for y in terms of x, all right? Then according to the formula, says the length is going to be, first of all, you have this ds, right? From this, it's trivial formula. But I'm going to change it to square 1 plus dy dx squared and dx. The domain for the x variable is from negative r to positive r. Okay, so you change the variable s to x. Okay, the formula on the left hand side is a trivial formula. Why? If you just look at this formula, it's the integral of 1 with respect to s from 0 to l. L is length of the semicircle. Okay, but now you change it to x variable. This kind of substitution. Then what you get, you have to differentiate. So derivative of y with respect to x. I'm going to give you the formula right away. Okay, it's going to be this. Okay, then you square. Looks pretty complicated. Okay, you just differentiate. Use a chain rule. So derivative of y with respect to x is going to be use a chain rule, right? This is going to be actually half of r squared minus x squared, then negative 1/2, then multiply negative 2x. Okay, there's a negative sign, but it's when you square it and you cancel out. Yeah. Okay. So this, after you simplify, this is negative x of that. All right, so let's simplify it. But when you add them together, numerator is just r squared. So you get r, when you take it out, r squared minus x squared dx. Okay, after you simplify. Because r squared minus x squared plus x squared is r squared. Square r squared is just r. Okay. How do you solve this? How do you evaluate this integral? How do we evaluate this integral? Well, the most natural substitution is the trigonometric substitution. So you have to use the trigonometric substitution. R cosine theta. Okay. Theta is x is from negative r to positive r. Theta is from negative pi over 2 to positive pi over 2. Okay. So it's going to be negative pi over 2 to positive pi over 2. You change it to another variable right now. R. And this is r squared minus r squared sine squared theta. And that is r cosine theta d theta, because that's the dx. All right. Actually, you cancel out. Just two cancel out. Because the denominator is just r times cosine theta. So you only get the integral from okay, the integral, right? R and the theta. R is the intermediate theta. So it's just pi times r. So pi times r is the length of the upper semicircle. Okay. let's go back to semicircle. Okay, we are going to study this a little bit later. We can describe this semicircle in another way, and we can introduce another parameter. Okay, so you can say x equals r cosine t, y equals sine t. When t equals 0, you are here, and you rotate counterclockwise. When t equals pi, you're here. Okay, and you at the two endpoints. So here t equals 0, here t equals pi. Actually, t is the angle when you rotate. So if you describe the point on the curve using another parameter t, then actually it's much simpler. The problem becomes. Okay. So formula. The arc length, we don't know what is there. This is our trivial original formula. Then I'm going to change it to ds. What is ds? dx squared plus dy squared, right? Right, that's a ds. And we don't know the interval yet. There's two variables there, so we leave it open. Okay, we're not going to mention the intervals. Now, sometimes we just simply put the curve C here. Okay, so now I divide both. I take dt out. Okay, it's going to be dx dt squared and dy dt squared and 10 multiplied dt. And t is from 0 to pi. Okay. Yeah, you divide dt. Basically, you divide by dt and multiply by tt. You know, divide by dt, multiply by tt. Okay. Then you move dt into the radicals, and you get dx. Okay. You can think about this. All right. So what is the derivative of x with respect to t? That is negative t r sine t. And here r cosine t squared. And square root and dt. And what is inside is just r squared, because cosine squared plus sine squared equals what? Okay. So it's just r squared. It's independent of t. R squared is r. And the interval is from 0 to pi, so just pi r. You get the same result. Okay. It's interesting, right? So I always memorize this formula. It's the integral, the length is going to integral of ds. That's it. Then ds could be is going to be square root of dx squared plus y squared. Then you decide whether you're going to take dx out or take a dy out. Then you have to determine the domain for the variable y or variable x. You can also take another variable out, t. Then you have to divide by dt and multiply by dt. All right. So it depends on how do you describe the relationship between x and y. X and y, the coordinates point on the curve. That changes. Okay. That changes. Yeah. And yeah, that changes. So if this is let me repeat again. So you have you have a curve, right? And this is a point x and y, right? And ds, you always have this special triangle, right? Triangle, and this side is dx, this side dy, and that side ds. ds is the length of this hypotenuse of the right triangle. Okay, so the total length is just add them together. Integral means add them together. Okay, or for those tiny bits, yes, add them together. And the s is, that means this is a picture again. So it's from 0 to L. add them together means the integral of ds. Okay. Then from this this picture, the Pythagorean theorem, it's going to be dx squared plus dy squared. I still put, but I cannot put the specific intervals here. I don't know which variable we're going to use, right? So let me, yeah, if this curve is c, I just put c here, right? Then you decide which variable you can use. X and y are left, okay? Y is function of x, or maybe x is function of y. Maybe x and y both a function of t, okay? Right? So here's a problem, okay? We are given the curve. Curve is given by this equation, okay? Y is between 0 and 2. Find the length, okay, of the curve. Okay, so find the length of the curve determined by this equation. What does that mean? That means, okay, first of all, draw the graph, right? When y equals 0, x is 0. When y equals 2, x is also 0. When y increases, x is actually negative. Okay, so it goes like that from here to here. Okay. Let's see, you can quickly sketch the graph. Y x is negative. So from this product, you can see that y is between 0 and 2, so y minus 2 is negative. Okay, so it's negative. Okay, this is always negative. Okay. So an arbitrary point x and y on the curve x and y related by this equation. So here clearly x depends on y, but the dependence of y on x is not trivial. Yeah, x depends on y, y also depends on x, right? But y depends on x. You can solve for y in terms of x. But this is very complicated formula. Okay, use the Kojak formula. So here clearly the length is going to, right? You have to take dy out instead of dx. So dx over dy, because the dependency of x on y is simple, just a polynomial. Right? The y value is from 0 to 2. So you should write down this. Okay? You should use y variable for the integral. Right? Then the derivative of y, a derivative of x with respect to y is given 2y minus 2 square plus 1 dy. Okay? What is next? Should you multiply this out? No. Okay, you just make it more complicated. So 2y minus 2 is there, right? So what you should do is you denote this part by u, for example. You let u to be 2y minus 2. Okay? When y is 0, what is u value? When y is 0, u is negative. When y equals 2, u is going to be positive. Okay? So corresponding domain for u. Yeah, okay. So now this is integral square root u square plus 1. dy is half of du, right? And u from negative to positive. That's it. When y equals 0, u is negative. So you get this integral. Right. Then you have a option how to evaluate this integral. It's very complicated. You can use substitution to do that. Right? You can use substitution to do this problem. You know, you have to use a hyperbolic sine, hyperbolic cosine if you want to do that. Right? Because how do you make a u square plus 1 become another square? You have to get rid of the radical, right? And I know that hyperbolic cosine square minus hyperbolic sine square plus equals 1. So you can use that one to solve the problem. You can also use 1 plus tan square equals secant square. Use that formula, okay? But here we just use we look at the book. There's a formula in the book side, Webex side. We just use that book, okay? I use that formula in the book. So the formula actually is a formula number 21. Yeah, you can find out. Okay. So first of all, I have 1/2 here. What is the antiderivative of square root of u square plus 1? It's going to be half of u square plus 1, then half of natural log u plus square root of u square plus 1. Well, it's indeed difficult to get the antiderivative. Yeah. Okay. So you have to. Can we simplify this? Yes or no? Okay. That's really good test of a skill. Skill. Okay. So the first part, right? If you plug 2 and negative 2, if you 2 over 2 minus 2 negative over 2, I think it's going to be yeah. If you put 2 here, the square root of 5 plus natural log of 2 plus square root of 5. Okay, that's the first part. Minus the second part is going to be negative 1/2. It's so just negative. Okay. So the question, how do we simplify? Right? You have a square root of 5, so 2 square root of 5 is square root of 5. And then I have a quarter natural log 2 plus square root of 5. Here's negative 2 plus square root of 5. Jesus. Okay. So I have a quarter. Now, can you simplify the first? Can you simplify the first? Okay, you can rationalize the denominator. Okay, so it's 2 plus square root of 5, negative 2 plus square root of 5 is going to be, okay, is going to be square root of 5 minus 2, square root of 5 plus 2. Here, square root of 5 plus 2 squared. And the denominator is just equal to 1. Okay, that's it. Square. So actually, so you can put, okay, so after you simplify a little bit, so this will be the length of that curve. I'm surprised. Yeah, that is going to be the length of that curve. Right? The difficult part is to evaluate the integral. But if you use a Maple or some like software on computer, you can just enter the function and also tell the machine computer, what is the interval, right, for the integral. Then click return, then you get this number. Okay, very quick, within a second. Computer is pretty fast right now. Okay. All right, so our next problem. Yeah, in most of cases, it's hard. We cannot evaluate integral, so we carefully choose some functions, so you're able to evaluate the integral. So otherwise, I just ask you to set up an integral for the length of the curve. That's it. Right? Or even you can evaluate, but it takes too much time. We don't have enough time. I just want to set up an integral for the length of the curve. So curve is defined by the following equation: y equals 3 plus half hyperbolic cosine 2x. X is between 0 and 1. Okay. Find if you ask it to find the exact length of the curve, then you have to evaluate integral. Okay. You have to evaluate the integral. You don't need to sketch the graph. Okay. Based on the information you're given here, y depends on x. So y is a function of x. Right? So the length is going to be the integral from 0 to 1 square root of 1 plus dy dx square dx. You write down this first. Okay? You write down this first before you try to evaluate. Then find the derivative of y with respect to x. How do you find the derivative of y with respect to x? You differentiate y, and hyperbolic cosine become hyperbolic sine. Then you 2x get 2. So just hyperbolic 2x and square dx. Okay, when you differentiate. So the derivative of y with respect to x is just hyperbolic sine 2x. Then what? Are we able to get rid of the radical? Yes, we know the formula. Hyperbolic x squared minus hyperbolic sine x squared is going to be what? This is identity. It's different from cosine squared plus sine squared equals what? Hyperbolic cosine squared minus hyperbolic sine squared is going to be minus. So therefore, if you see 1 plus hyperbolic sine square x, that is going to be cosine hyperbolic cosine 2x squared, right? Right. Then you can get rid of. It's not too bad, right? Okay. So the entire derivative of hyperbolic cosine 2x will be hyperbolic sine 2x, but you have to divide by 2. Because when you differentiate, you get 2, right? So it's from 0 to 1, and let's, okay, hyperbolic sine 0 is 0. So this is answer. It's the exact value of, it is the exact value of the length. Okay. So it's very important to show 2 steps first. Then it's up to you, if you're able to figure out how to evaluate integral, then you continue. Otherwise, you leave that. You can move on to the next problem. Okay. So most of the problem given on the Crystal test, you can get rid of radicals. So remember that. Be careful. Yeah. So you can evaluate integral. So here, x is determined by y to the 4th power divided by 8. Here, 4y cubed. Y is between 1 and 2. Okay. Find the exact length of the curve. Okay, should we draw the graph? It's not necessary. Okay, it's a function, x depends on y, not the y depends x. Okay, but I know the domain from y for the y variable, right? From 1 to 2. Okay, so clearly the length is going to be from, should be used you should use the y variable instead of x variable, right? Then dx over dy. Y is from 1 to 2. All right, so now the most difficult part is to handle the terms inside the radical. This requires some very basic algebra skill. Okay, let's do that. So I find the derivative of x with respect to y. So I get 4y cubed, right? Plus, be careful, this y to the negative 3, so it's minus, and 3, 4, y to the 4th square, and plus 1. This is a negative. Let me check. Did I? No, I copied wrong here. You are not able to evaluate this integer. This is not the y cube. Okay. You see some small change here. This is it's 2. Yeah, that is correct. Okay. When you differentiate this, right? Derivative of y, 1 over y square, right? And this is derivative y to the negative 2, so it's negative 2y to the negative 3. Then you go back to this form, right? It's 2 negative 2 over 3. All right. So how can I change it to something square? Okay, this is going to be half of y cubed minus half. Can I express it as something square? Then I can get rid of it because this is inside the radical. I want to get rid of radical. It's not a sine cosine here. So just rational functions. Okay, so you squared first. Okay, let's do it. If you squared first, I get y to the 6 and here 4. All right, then minus twice of that. Actually, that's 2. It's 1/2. Y cube cancel out. 1/2 times 1/2 times 2 is just 1/2. And then you square, it's 4y to the 6 and the plus 1. Okay? Now, this is a negative sign. This is negative sign here, right? If I believe that if I change it to I change it negative to positive, I will get a positive 1/2. Clear, right? Yeah, this is negative sign that corresponding to each other. Yeah, if on top, if it's plus, then I also get plus 1/2. This simple observation makes it to get a complete square. Okay? Why? Because if we negative 1/2 plus 1, right? You get y to the 6 over 4 plus 1/2 plus. Okay? Then you see, okay, then I'm pretty sure this is just equal to y cubed over 2 plus 2y cubed squared. Right? Yeah, because I changed the negative 1/2 to positive 1/2. So you can go back to the square again by changing the sign. So now the integral, the length is from 1 to 2 square root of dx of dy squared plus 1. It's going to be square root of this. That's just y cubed over 2 plus Yeah, no square, right? Okay. So let's find the antiderivative of this. I needed to rewrite this, okay, as a sum of power functions. Then I can figure out the antiderivative, okay? Antiderivative is going to be, right, plus half -3 plus 1 -2. So this is will be the antiderivative. Okay. So we can take, for simplicity, we can take, well, I can take, yeah, I can put that, right? It's going to be 8, 2 to the 4th power, minus 1, minus 1/8, 2 to the -2, minus 1. Well, you can simplify a little bit, but then not much you can do here. Okay. After you combine all the terms, yeah, we can do that a little bit, right? So you can get a positive number, 33 divided by 16, right? Just one fraction. Now I'm not going to evaluate integrals. I just want to set up an integral for the length, okay? Because some integrals are really very bad, and some not even can evaluate the integral by hand. You have to use a computer to approximate the number. So, but set up an integral is very important, because otherwise, how can you tell the computer, right? You want to find the length, right? The computer maybe is a primary step is just the computer can evaluate integrals. You still have to give the integral to the computer, right? So set up an integral. Yeah, we have to know how to set up an integral. So read the question carefully. If I ask you to set up an integral for the arc length, then don't evaluate. Don't waste time. Of the curve is y equals natural log cosine x. X is between 0 and pi over 3. Cosine x is always positive. X between 0 and pi over 3. Okay. So this is a well-defined curve. If you have to draw the graph, it looks like that. When x equals 0, anyway, it's negative. It's going to be like this. Here's pi over 3, and this is 0. Because cosine x is smaller than 1, natural log of number smaller than 1 is negative. That's why the y value is negative, so this graph is under the x-axis. All right, set up the integral. First step, the length is going to be, so you know you're going to use the x variable. So you can write down directly from 0 to pi over 3, it's 1 plus dy over dx. And that is not the final answer yet. So you have to tell me, you have to simplify what's inside the radicals. Okay. It's 1 plus, so derivative of y with respect to x is going to be cosine x. Then you differentiate negative sine x, differential cosine x, and the square dx. Okay. Step by step, you simplify. It's 1 times tangent square x dx, right? But tangent square, 1 plus tangent square x is going to be secant square x. So it's going to be secant, but actually it's going to be 1 over cosine x dx, right? You can take. So even you see this function, even you see this function very simple, but don't waste time to evaluate the integral, because I just asked you to set up integral. Clearly stated, I'm not asking to evaluate it. Unless it's very obvious, you can put a number there. But if this number is wrong, I have to take points off. Yeah. But in this, for this one, for this problem, you know, maybe somewhere else, I'm asking to evaluate integral. Okay, like the integral of 1 over cosine x, but not for this particular problem. Okay, you can get the exact value by hand, not by computer. You can evaluate this integral. Okay, this is an integral of a secant x. We know how to evaluate this integral secant x. Okay. Set up an integral for the arc length. Okay. The graph is given by this equation. X, no, actually the y is between negative and the positive. Okay, how can I understand this function? This is actually is x is e to the y squared, right? X is e to the y squared. Or you can also write y to be, no, yeah, you cannot solve for y because you don't know y is positive, so y is plus minus 1. Okay. So the graph is, it looks like that. It's a symmetry about x-axis. Okay, this is a point when x, yeah, e and the y is negative 1. When the y is positive 1, you also have e. Right. Okay, so when y equals negative 1, x is e. When y is positive 1, x is e. So you have a starting point and ending point. We just want to set up an integral for the arc length of this curve. Step 1. You write, yeah, you should know this is going to be the integral with respect to y variable. And that will be dx dy squared plus 1, and then y from negative 1 to positive 1. All right, so you differentiate. Okay, how do I differentiate? Differentiate x with respect to y is going to be 2y e to the y squared and square plus 1 dy. Okay, it's complicated function we are not able to evaluate. Yeah, it's not easy to evaluate this integral. Okay, so here's another question. Let me draw the picture here. This is a equation x 2 over 3 plus y2 over 3 equals 1. Okay, and x, y can be they are both can be negative. Okay, it goes like that when x equals 1, y equals 1. Okay, it's a symmetric picture. You can solve for y. You know, both x and y can be negative. Okay, because y, you see, this is by definition is going to be x to the 1/3 square, and the x to the 1/3 is defined for any x. Okay, could be x, could be negative, could be positive. It's different from x 3 over 2. So anyway, the picture is given. This is it's not circle, right? And when x equals 0, y 0, when x equals 1, y 0, and when x is 0, y is 1, and the y also could be negative 1, right? So those 4 pieces are identical. Yeah, let's say set up an integral for the arclets. Okay. I just needed to set up a integral for one piece. It's a symmetric. So the length is equal to 4 of the integral, right? And if you can view this like y equals f of x, right? So that would be dx, right? X is from 0 to 1. This is a dy over dx squared. That's one way to set up integral. Right. There are many ways to set up integrals. Okay, this is one. X is start from 0 to 1. So you get x from here from 0 to 1, then you get the corresponding y value. Okay. So you define how do you solve for y? Y to the 2/3 equal 1 minus x to the 2/3. So you solve for y, you get 1 plus and 2 over 3. Oh, 3 over 2. Yeah, you solve, right? It's minus here. Okay. So dy over dx, use a chain rule. 3 over 2, 1 minus x to the 2 over 3. And 3 over 2 minus 1 is 1/2. Then you differentiate inside. That's negative 1/3. That's it. You can simplify a little bit. 2/3, 3.5, and 2/3 is going to be negative. X to the negative 3. All right, so the square, let's continue. Dy dx square plus 1 is going to be 1 plus square x to the 2/3. 1 minus x to the 2/3. That's it. Not too bad. Okay. It is going to be, after you combine it, I cancel it out. Just only 1 of x to 2/3. Wow. All right. So this is going to be 4 from 0 to 1, and the square root of this. And actually, you can evaluate this integral. Right? You can evaluate this integral, and this is going to be x. Okay. And this is improper integral. Actually, it's improper integral. And you can find the antiderivative of that. It's going to be, what is the antiderivative? 1 by x 2/3 x to 2/3 from 0 to 1. Okay. Yes. Okay. So I got 6. Wow. All right. So this strange curve, okay? This strange curve, the total length is going to be 6. Yeah. Okay. Now we can evaluate this integral after we set up integrals. This time it's trivial, right? It's just a power function, the integral power function. So you just evaluate. You can evaluate that. Okay. Now there's another way to parameterize parameterize this curve. Okay. So let me pick up this. Draw the picture here. I know this is going to be viewed like x to the 1/3 square, y to the 1/3 square equals 1, right? And compare with cosine square t plus sine square t equals 1. What you should set? Clear. You should set x to the 1/3 equals cosine t, y to the 1/3 equals sine t. Okay. In other words, you get x equals cosine cubed, y equals sine cubed. Okay. So when t changes from 0 to half pi, then from half pi to pi, you will get all those 4 pieces. When this is t equals 0, t equals pi over 2, t equals pi, t equals 3 pi over 2. They're going around, okay? So the length integral, I just need to 4 times from 0 to pi over 2, okay? And then what is inside? Inside is a dx squared, dy squared, so I can dx dt square, dy of dt square dt, okay? So this is another integral for the same length. Okay, then you differentiate x with respect to t. The derivative of x with respect to t is going to be 3 cosine squared and sine t, right? Mm-hmm. And here's a 3 sine squared t and a cosine t. And we have negative sign here. Negative sign is okay, the square. And then you simplify. You can simplify, okay? I think it's 3 square, you can take it out, just 3, right? Cosine to the 4th power sine square t. And here, sine to the 4th power cosine square t. Can you simplify further? The answer is yes. You can take a sine square t, cosine square t out. Okay? Sine square t, cosine square t out. Then you get a cosine square t plus sine square t, but which is going to be 1. So the answer is square root of this is just sine t, cosine t, and dt. Okay? Yeah. And no radical then, right? Then what you get? You change this sine t, cosine t, 2/2 is a sine 2t, right? You change it to sine 2t. So it's going to be 6 from 0 to pi, sine half pi, okay, half pi. 2t dt. Okay, so the antiderivative sine 2t is going to be cosine 2t divided by 2 from 0 to pi over 2. Okay. So the answer will be, wait a minute, it's going to be 3 or not? It's going to be, no, it's going to be cosine pi minus, oh, I have the negative sign here, so it's negative, plus cosine 0. On the top, you get 2, so the answer is still 6, as you can see that, right? So it's the same answer, different way to solve the problem. Okay. Yeah. So let's have a quick review. You know, even I say it's you set up an integral for this curve. First of all, you look at the symmetry of this curve. You just needed to look at one piece. Then you do. It's up to you how to describe that piece of curve. This is going to be graph of the function. So you have to solve for the function. Then after you carefully differentiate and simplify, you end up with a power function. So it's easy to evaluate the integral and get 6. But you should also learn how to find equations for the curve using third parameter, okay, which is which is x equals cosine cubic t and y equals sine cubic t. And after you plug into the integral, then you simplify, and you end up with integral of sine 2t. It's not too bad. And then the value is still 6. You get same answer. And no matter which way to go, that's really magic, you know. Mathematics, no matter what, as long as it's correct method and no computation mistakes, you end up with the same solution. Okay, same answer. Okay. That's all for today's class.